Good morning again. My name is Manfred from Perception Park. Today I'm going to tell you a little bit about chemical color imaging for industrial applications. So let's have a look on the evolution of machine vision, starting with monochrome imaging, color imaging. The past few years we were talking a lot of 3D imaging, and now industry gets more and more interested into the chemical properties of objects. But what is chemical color imaging? Chemical color imaging, or CCI, is a visually guided process to make hyperspectral features accessible. It abstracts, standardizes, and calibrates hyperspectral cameras and enables the universal, repeatable application of hyperspectral cameras for the machine vision community. So let's have a look on this image. So we see here a plastic bottle with a paper banderole on it. So it's quite small data, 1 megabyte based on RGB. So we have thousands of image processing tools to handle those data. Sure, all the cameras provide standard interfaces like GigaVision and so on. But if we are interested in the chemical properties of these objects, we cannot find it here. We have to use, therefore, for example, hyperspectral imaging. But using a hyperspectral camera for the same scenery, we now have really huge data. It's now about 400 megabytes. Sure, it's based on hundreds of wavelengths. And to get out the information of interest is really complex, and there are no standard processing tools for that. Additionally, many of the camera suppliers do not provide standard machine vision interfaces like GigaVision and Camera Link. The answer to that is chemical color imaging. Getting the chemical features, chemical properties represented by chemical colors. The advantage is you once again have really small data, 1 megabyte based on RGB again, and now you can process those data with standard image processing tools. But what do we see now in this image? So we can see here that the red color is representing the PET plastic information, or the blue color PE plastic information, and green represents paper. But we can see there are some additional colors. So there is some purple color at the bottle neck or some yellow color in the middle of the bottle. What does that mean? We know, for example, that purple is a mixture of the color red and blue. By means of chemical color imaging, that means that it must also be a mixture of PET plastic and PE plastic. So this is now information which I can now handle with standard image processing tools. Bringing this to industry, we have two major challenges. The first challenge is find the application relevant information. And the second one, once we have found that information, how can we make an industrial application for it, for example, for sorting? Therefore, Perception Park provides a two-component software tool. We provide our Perception Studio to find the application relevant information, and once found it, we can easily apply it for industrial processes. The Perception Studio is a software suite for hyperspectral data acquisition, exploration, and modeling. It has encapsulated the most interesting scientific methodologies of chemometrics and spectroscopy, and we have encapsulated that by intuitive user interfaces and by a visually guided workflow. For us, it is very important that on every click, on every action you perform on your data, that you get direct feedback. In this example, for example, we have some rice with some wood in between and also some worms. Using our Perception Studio, we can generate the right image representing the rice in green, the worms in red, and the woods in blue. If we want to bring that to the application now, we can use the Perception Studio to compile that for our real-time processing engine, the Perception Core. The Perception Core, this real-time processing engine, you can understand it like an adapter which is translating hyperspectral camera raw data into chemical colors. It is running on a high-performance data processing platform, which is based on GPU, and the Perception Core abstracts and standardizes and calibrates cameras so you can use it for various cameras. And sure, it is chemical color imaging compliant and supports standard machine vision interfaces. How can we apply that in industry? So we use, for example, the Perception Studio on our notebook. to develop an application. Once we have developed it, we can compile it for the real-time data processing engine and then run it on the, for example, industrial PC as an adapter, translating it to our chemical colors, which you then can easily process with your familiar image processing tools like Sherlock, Common Vision Blocks, or Helcom. But what if we have some additional challenges like small size, low weight, or just low power consumption? Maybe you agree with me. It's pretty hard to bring such an IPC to a drone. It's like, doesn't work. Therefore, we proudly present our first system-on-chip solution based on the NVIDIA Tegra X1 and X2 data processing chip, which is very small, low weight, low power consumption, and it's really high efficient. The good thing here is there are various platforms which are already using this chip. So for example, in the top left corner, we see a supercomputer provided by NVIDIA, which is actually just in the size of a bank card. Next to it, there are also some suppliers providing carrier ports and various breakout ports for different interfaces, and there are already some housed Vision PC solutions. You can see all the solutions are really small, and the sensor as well. So why not bring it directly into the camera and providing a chemical color imaging camera or a smart camera? Sure, all these solutions are supported by our perception core, so they are chemical color imaging compliant, supporting standard machine vision interfaces. Why did we decide for this technology? Well, there are many fields where this NVIDIA Tegra chip is already used. So it's used in Nintendo Switch and Shield console. Also the Google Pixel C notebook is using that technology, and NVIDIA itself, they are also providing high-performance computers for AI in the automotive industry, so for self-driving cars and so on. So you can see there's a huge community behind that technology, which are pushing them forward really hard. So on the bottom right corner, you can see the development of the processing power of the NVIDIA Tegra chip. Good. So to sum it up, how to come to our application? Well, you have a concept, you use the Perception Studio to develop an application, you can easily compile it for your target hardware, and then you have implemented your perception core on our industrial GPU-based PC or on an NVIDIA Tegra platform to provide you high-performance products, like, for example, a sorting machine or a drone application. Where can you buy it? We have several partners around the world, so if your region is still gray, please contact us directly. And here I summarized some application examples which are already used. So on the first one you can see it's really good used for quality assurance for drugs. I think Stemmer Imaging is showing such an example. In the middle image, in the center image, we see moisture control, moisture detection in wood, but there are also a lot of applications where this technology is used, for example, for impurity detection in food processing and so on. So in this sense, thank you very much.